take it to the next presentation, and I'd like to introduce Eelco Dekker, our upcoming speaker, briefly. Eelco is the Chief Representative for Europe for the Methanol Institute, before which he was the Chief Marketing Officer for BioMCN. Has a lot of expertise on European opportunities regarding alternative fuel applications, with obviously a strong focus on renewable methanol. And he supports the Methanol Institute in gasoline blending and marine fuels to explore the opportunities to broaden the use of methanol. And prior to working for BioMCN, he's worked at various chemical companies and has a master's degree in business administration from the Erasmus University in Rotterdam. And with that, I hand it over to you, Eelco.
Thank you very much, Sebastian. This is a good way of testing whether the system works.
Yes, we hear you perfectly.
Okay, and you can see the video or the presentation on the screen as well?
Yes, we can.
Okay, well, it's a bit of a challenge because we found out that there is a bit of a time lag between the presentation on YouTube and what we do on Zoom. So but we'll figure it out somehow. Yeah. And with I guess in that sense, the challenges with technology, whether it's engine technology or IT, as a non-technician, sometimes are both probably as challenging. Without further ado, good morning all. My name is Eelco Dekker. I am the Chief Representative for the Methanol Institute. The Methanol Institute is a global industry association that represents the world's leading methanol producers, distributors, technology providers, and increasingly also more and more actual consumers of methanol that use methanol for a wide variety of applications. Challenges around technology are not limited to engines only. Sorry about that all. So to go back to my story, and as was already briefly touched upon by Sebastian and by Martin, when we look at methanol today, demand is well over 80 million metric tons, and the majority of that methanol today is still primarily produced from fossil resources, whether it's natural gas or coal. But there's clearly a growing interest in producing methanol from quite a broad variety of different renewable feedstocks. And when you have methanol, whether it's made from fossil feedstocks or from renewable feedstocks, chemically it's identical. That means that anything you produce from fossil methanol today can be produced from renewable methanol as well. And even though methanol is still primarily a chemical building block, nowadays almost 1/3 of global methanol demand is already in various energy applications. And in my next few slides, I will share some examples of that with you. But before I do, I just wanted to touch with you briefly on the various developments around the use of or the production of renewable methanol around the world. Actually, a few years back, the Methanol Institute published a document that has highlighted all these different pathways, which is available on our website. And later this month, MI, together with IRENA, the International Renewable Energy Agency, will publish a new document on the latest status of production of biomethanol and renewable methanol around the world. But in broad sense, there are a couple of ways to produce methanol from biogenic feedstocks, either through fermentation, where you ferment biomass into biogas, which then can be converted into methanol in basically the same way that natural gas is converted into methanol. Or you gasify biomass or municipal solid waste to produce a syngas, which is then reacted into methanol. And with the recent opening of the new facility of Södra in Sweden, it is also interesting to see the potential of using or producing renewable methanol from pulp and paper mills, because that by nature already produces a biogenic type of methanol. And more recently, I think probably many of you know the example of Carbon Recycling International in Iceland that convert renewable electricity from geothermal heat and CO2, which is locally available, into methanol. But we see an increasing number of projects in the space of synthetic or e-methanol. There have been recent announcements, amongst others, in Belgium from the North Sea Consortium in Ghent, a project in the port of Antwerp. There's Liquid Wind in Sweden that is looking to produce renewable methanol from wind power offshore. There's the Statkraft project in Norway. There are projects in China. So this is certainly an area that is gaining a lot of traction. And in the previous presentation, there was a question around efficiency as well. I would all recommend to download a recent paper from Frontier Energies in Germany that looked into this question around efficiency, not just from the efficiency of the engine, but also the efficiency of the production processes. And basically, it raises the question whether, from a sustainability perspective, energy becomes the most important topic when you take into consideration that basically the availability of renewable energy doesn't have to be the restricting factor. In principle, when we're dealing with depletable fossil resources, energy efficiency is very important. But when we know that we can generate as much renewable power as we need, then efficiency in the decision criteria becomes less of an important factor as well. It becomes much more of a determining factor for the economic, the cost of a process. So if you have a less efficient process, obviously the finished product is more expensive. But the key thing here is, why do we produce renewable methanol, biomethanol, is that it helps reduce the carbon footprint of different applications, and especially for different types of energy applications. And when we look around the world how methanol is being being used as a fuel, it's interesting to see that it's not only limited to one part of the world. We have often spoken about the use of methanol as a fuel in China. Probably everybody knows about the use of M15 fuels in gasoline vehicles. But actually, there's a lot of different applications in Asia, in Europe, but also in the Middle East, in Australia, in South America, and also North America and Canada. And that ranges from cars to ships to cook stoves to electricity generation. But rather than taking you through all these different examples around the world, as a marketeer, obviously, I've tried to segment this a little bit more into specific areas. And broadly, you can distinguish 4 segments for the use of methanol as an energy carrier. It's either as a fuel for road transportation, or as a clean fuel in shipping, a fuel for heating, or a fuel for power generation. And those 4 categories are the basis for my next couple of slides. Starting off with road transportation. And as Martin explained in his presentation, methanol being a high octane fuel, typically our industry looks at methanol as a gasoline component or a gasoline displacement. So many of the examples that we see around the world focus around the use of methanol either as a low blend component in gasoline fuels, something which is being done amongst others in New Zealand and the UK. But we're seeing a growing interest in mid-level blending as well. The M15 example in China, where demand for methanol reaches close to 5 million metric tons per annum already as a fuel component. But closer to home here in Europe, we have developments around the use of A20 blends, which is 5% ethanol and 15% methanol. One of the companies that is leading this work is Eni in Italy, together with Fiat Chrysler. And one of the reasons why they're doing this is because they can demonstrate that they can actually reduce the tailpipe emissions, the CO2 tailpipe emissions of existing road-going vehicles without any modifications. But if you look into what can be done in terms of even higher shares of methanol, there's an interesting project in Denmark right now that is looking to demonstrate the conversion of locally produced biomethane into biomethanol to run M85 vehicles. In Australia, Coogee has done a lot of work around gasoline ethanol blending in flex fuel vehicles. So typically cars that were designed to run on E85 that can also run on blends of ethanol and methanol and gasoline. And then going all the way to 100% methanol in China, there are now over 20,000 certified taxis that run on neat methanol, and that number is increasing by the year. And one of the reasons why this is increasing because it is not only contributing to lower emissions in the cities, but it is also an attractive economic solution for the taxi drivers. Then again, methanol is also being used for diesel applications, obviously as a feedstock to produce biodiesel. Martin spoke about the example of MD95, but we're also seeing developments around either converting diesel engines to run on spark ignition mode in similar fashion as we know for some of the LNG trucks that exist in Europe. But there are developments around the use of methanol in combustion ignition engines as well, using diesel as a pilot fuel for trucks. And something that I think, especially in Sweden, is something that is still being looked at as well, is the use of DME as a diesel substitution. And in Germany, amongst others, Ford in Aachen is researching the possibility of producing OME, which is, in simple terms, a liquid alternative to DME. But even in electric mobility, if you use methanol as an energy carrier and you have an onboard fuel cell or an onboard methanol reformed fuel cell, you can produce your hydrogen on demand that then generates the electricity that is needed to run the electric engines. Examples include a sports car from Gumpert, but the IOH U5 will also use a similar technology. We have plenty of examples where direct methanol fuel cells are being used for lower power demand in forklift trucks. But if, for whatever reason, the option is not to use a reformed methanol fuel cell, it is also possible to practically transport methanol as a hydrogen carrier to a fueling station and do on-site reforming for whatever and whenever the methanol or whenever the hydrogen demand arises. Now, Sebastian spoke about the Fast Water project. It's one example of a lot of different projects that we see around the use of methanol as an alternative fuel in shipping. And here too, I try to segment a little bit between the different types of users. We have dual fuel engines, new build and retrofits. The Stena Germanica is a well-known example. Waterfront shipping by now has over more than 10 ships operating on methanol already, several thousand hours of non-stop operation. Standard Bulk and Proman recently announced that they will start building further cargo carriers or methanol carriers to use methanol. And I don't want to go into too much detail, but we see examples of the use of methanol as a fuel for fuel cells on board of ships as well. For smaller ships to actually provide the energy for fuel cells to provide the energy, or for hotel loads. So there's a lot of work going on in this particular space. But it's not just in transportation. It's also to produce electricity either through fuel cells for remote areas, example, for mobile telephones, gensets. We have an interesting project here in the west of Europe where we're looking at shore power through gensets using methanol as a clean fuel to provide electricity to ships. In Israel, there are turbines running on methanol that previously ran on diesel, but when they ran on diesel, the local emissions were so high that they were only allowed to run a minimum amount of hours, where now with methanol, these turbines can run non-stop. And then a very important development is the use of methanol as a displacement for solid fuels in industrial boilers, for example, in China. There are now over 1,000 units running on methanol. Today, the demand is approximately 2 million metric tons, but it is expected that that demand will increase to at least 5 million metric tons. The use of methanol as a fuel in ceramic and glass kilns. And the interesting thing there is that the flue gas is actually cleaner than it was with the coal. So the quality of the product improves. China smokes, I think 1 in 3 cigarettes that is being smoked is smoked in China. So tobacco drying is a very important industry in China. They are increasingly using methanol as a fuel as well. And then cook stoves. Obviously, if you use methanol as a fuel for cook stoves rather than coal or wood, your local air quality improves a lot as well. Simple example, in the city of Hefei in China, a city with over 8 million inhabitants, there are over 2,000 medium-sized, large-scale restaurants, and 1,200 of them use methanol cook stoves. And interestingly enough, the supply of the methanol is managed through the Internet of Things. So methanol is certainly much more used as an energy carrier than just in road or marine fuels. It's gaining traction in a lot of different areas. And the main driver for this is, to a large extent, also driven by legislation. On the one hand, it's driven by the need for renewable energy. It's driven by the need for solutions to store increasing supply of renewable electricity. But obviously, there are big benefits for not only carbon emissions, but also for local air quality. And for many developing nations, it's also an interesting way to become less dependent on energy import and to develop their local energy supply. So to summarize, yes, methanol demand as an energy carrier to a large extent is driven by legislation, but the use of methanol and their derivatives provide a tremendous amount of benefits, especially when it's made from sustainable renewable feedstocks. And as I hope I've demonstrated to you very briefly, it can be used in many ways as an energy carrier for road transportation, for the maritime sector, as well as for generation of power and heat. But in order for methanol to continue to grow, I would encourage everybody to take the words from today's conference and spread the word as well, because we see still a lot of prejudice around methanol, and not all of that is necessarily fact or science driven. There's a lot of things still circulating around methanol which are not factual, and a lot of the benefits are simply not being seen. So I thank Sebastian and Martin for all the work they're doing to spread the word, and let's continue to support the work that they're doing in this area. Thank you very much.
Thank you, Eelco. We have just 1 or 2 minutes left for questioning, but there's definitely one up here that I would like to run by you. And you touched upon legislation. We have a question here on how to push EU authorities to accept that methanol is a valid e-fuel like hydrogen is one, where mostly what we hear now is a very strong push towards hydrogen, and all the rest is gone. So any inroads there, any possibilities to try to open up the field?
Well, certainly. I mean, some of the examples that I mentioned around the e-fuel or e-methanol projects are directly linked to European subsidy programs, the European Innovation Fund, for example. So the projects that are trying to develop these types of processes are certainly interacting themselves with the European Commission. But you're absolutely right that there seems to be almost a political prejudice towards hydrogen, and not a full realization yet that hydrogen, even though it's a crucial molecule, also has its challenges. And that's why MI and several of our members are actively interacting with the Commission and with policymakers to explain that in order for the transition to happen more quickly, it is important to also recognize the relevance of synthetic fuels. Obviously, from our perspective, we want to focus on methanol, but from a broader power-to-X perspective, this can also be synthetic methane or Fischer-Tropsch types of diesel. We think, obviously, that methanol is going to be one of the more viable pathways, but I agree. There's still a lot of work need to be done to convince and explain to politicians how this can be done. I think what you're doing here today is a great example of how we can spread the word and hopefully educate people around what can be done.
Okay, thanks, Eelco. I'm afraid, given time, that we'll have to leave it at that for the time being. I hope you can join the main Q&A session, and then we will have further opportunity to get back to you with the questions.
I'll stick around, and hopefully next time, the challenges around Zoom are less limited, are less restrictive.
Yeah.
Thank you very much.
Thanks again, Eelco.